to learn some math. Learn some math.
It's time to solve some systems, okay? So at the end of this, we want you to be able to say, I can solve solutions of systems of linear equations in two variables by graphing. All right, let's get going. So before we begin this whole unit and this whole journey that we're going to do, we have to define a few things first, okay? And the first thing we're going to define is what systems of equations really are. And what they are is they are a group of two or more equations, okay? That's the part of the systems, okay? Equations we know is just something like slope-intercept form, y equals mx plus b, y equals 4x plus 3 or something like that. Systems is where we group two or more of those together. And the solution to a system, okay, we're continuing on here, the solution to a system of an equation problem is the point at which a value of x can be used in all equations to give you the same value of y. Okay, so that means that essentially once you've solved the two equations together substituting the same value of x and the same value of y, we get the same exact answer. Okay, so this may seem confusing right now, but right away I want you, given the equation y equals 4x plus 3 and negative 3x minus 3y equals 6, I want you to give a solution to the systems of equations. Now I told you that x and y are the same for each one of those. So before even trying to look at it too long, pause the video, take 10 seconds, try to think what would x maybe have to be and what would y maybe have to be. So I hope you at least attempted a guess. I know right now it's kind of confusing. I don't know exactly how to do this, that type of thing, but I hope you at least attempted it. Now there's a few different methods, but the one we're going to focus on today is graphing. And one way to solve that would be, so that's your first blank there, one way to solve a systems of equations problem would be to graph the equations and to see where the two lines intersect. Okay, so graph the equations and see where the two lines intersect. The point of intersection then would be your answer. Okay, that would be the solution to the problem of systems of equations. Now there's special types of systems of equations. Okay, a consistent system will have at least one solution. Okay, an inconsistent system will not have a solution, meaning that the lines will never touch. That means that if the lines never touch, we call that a no solution, that there's not a solution to this. An independent system, okay, these are some big terms you're going to need to know. An independent system has exactly one solution. Okay, so remember, a consistent system has at least one solution. An independent system has exactly one solution. There's no more than that. Whereas a dependent system has infinitely many solutions, meaning essentially that the lines never separate, that they're the exact same line. Okay, so I'm going to push this down a little bit and we can see kind of what I'm meaning by this. Okay, a consistent and independent, if we have an equation like that, if they're consistent, meaning they have at least one solution, and independent, meaning there's exactly one, there is only going to be one solution. It's going to have different slopes. The two lines linearly will have different slopes, and the graphs will look something like this, where you have two lines intersecting. A consistent, meaning there's at least one solution, and dependent, meaning there's infinitely many solutions, they're going to have the same exact slope and the same exact y-intercept, okay? And it's going to look something like this, where the two lines actually graphed make one line, okay? Now, an inconsistent system does not have any solutions. It's a no solution, and it has the same slope but different y-intercepts. They're parallel lines is what we will see for an inconsistent system. So we're going to go on to some examples here. And this first question here is to solve each system by graphing. Now we're given y equals 4x plus 3 and negative 3x minus 3y equals 6. And so what we have to do is we have to graph each of those lines. Now, this first equation is pretty easy. That's in slope-intercept form. And so all we have to do is just put the y-intercept at 3 And we know our slope is 4 over 1, okay, which means a rise of 4. Or you can drop 4 and go back 1. Both would work. Rise 4, go over 1, or drop 4 and go back 1. It means the exact same thing. Essentially what we did was a negative 4 over negative 1. And we're going to just graph that real quick by connecting these dots together. And voila, we've got our first line. That's the line y equals 4x plus 3. Okay, now this second line, this is not in any, this is in standard form. It's a little bit more difficult. Essentially how we do this is where we have to substitute 0 in for x and solve for y, and then substitute 0 in for y and solve for x. What it does is it finds the x and y intercept is what we're doing. So let's go ahead and do that. Remember, to find the x and y intercept, you have to first write the equation twice. This is last unit type of stuff. And we're going to get rid of the x on one of them, get rid of the y on the other one. And so we're given negative 3y equals 6. So to solve for y, we just have to divide by negative 3 on both sides. We end up getting y equals a negative 2. Same thing here, divide by negative 3 on both sides here. This just happens to give us the same. So we have x is equal to negative 2. That means the y-intercept is at negative 2. And the x-intercept is also at negative 2. Okay, so we just have to graph these lines here. Graph them together, put on our little arrows. And we see that the point of intersection is about at negative 1, negative 1. And so our answer to this would be negative 1, negative 1. That's where the two lines intersect. So the solution is when x is negative 1 and y is also negative 1. That's how you solve using graphing. Let's do another example of this though. Same type of scenario here. We have to solve the system by graphing, except we see that this time this is not in any type of form, and this one is in not any type of form either. So we have to do some work here to be able to figure out what these would be. Now you can do a few different ways. What we could do is we could do the substitute 0 in for x and 0 in for y and find the x and y intercepts, or you could also try to solve for y and put it into slope intercept form. So let's try that for this first equation. We've got 0 equals negative 2y minus 6 minus 2x. And what we're going to do is we want y on one side of the equation, so I'm going to add 2y to both sides, because that'll give me 2y is equal to, I'm going to rearrange this a little bit, negative 2x minus 6. And we see we're almost into slope-intercept form, where all we have to do now is just divide by 2 to all terms, and we get y is equal to negative x minus 3. Okay, and we can graph that. We can put negative 3, the y-intercept's at negative 3, and the slope is a negative 1 over 1. That means we're going that direction here. And we can graph this line. So let's do that real fast. It's going to look something like this. Okay, and now let's take our second equation. Remember, our second equation was 6 plus 2y equals negative 2x. And we just have to get y by itself, so we'll subtract 6 from both sides first. And we get 2y is equal to negative 2x minus 6. Divide by 2 on both sides to all terms, and we're left with y equals negative x minus 3. Now what do you guys notice here is that these are the exact same equation. They're the exact same equation, and so what we've done here is we've already graphed that line. Both lines are the exact same. And so the answer to this type of a problem is infinitely many solutions. Infinitely many solutions. This is a special type of solution, okay, where every single possibility for x and y is true. That's this type of solution. You could choose any x and any y and substitute it into either equation and get the exact same answer. So example 3, we're given two equations. This first one is in standard form, and I've already rewritten it here. And the second one, it's actually, that one's in point and slope form. And so we could do a couple of different things. We can still try to substitute 0 in for either for x and solve for y, and then do the exact same thing by plugging in 0 in for y and solving for x. Or we can solve for y. And this time I want to solve for y again, just because I think it's interesting to see our answer. Okay, so we're going to go ahead and just solve for y on this first equation by subtracting 2x from both sides. And that'll leave us with negative 3y is equal to negative 2x plus 6. Then we just divide by a negative 3 to each term. And we are finally left with y is equal to a positive now 2/3 x minus 2. Okay, and we can graph that. Our y-intercept is at negative 2, and the rise is 2, run of 3. So we've got our 2 points, and we can graph this on our coordinate plane here. Extend the lines both directions. And then we have to do the exact same thing to this other equation now by solving for y. Now y is already solved for, but we need to kind of distribute that 2/3 into both equations here. So let's do that. We've got y equals 2/3 times x is just going to give us 2/3 x. And 2/3 plus 2 is actually going to give us, if we distribute that, 2/3 times a positive 2 is actually going to give us 4/3. And the way I got that is I just multiplied 2/3 times 2 over 1. 2 times 2 is 4, 3 times 1 is 3. And that's how I got that number. So our y-intercept is at 4/3, which is about 1 1/3. And the slope is a rise of 2, a run of 3. And so we want to graph that line as well. We get something like this. Now our solution is where the lines intersect, and what we see here is that the lines don't intersect, and that's a problem. But if you notice, our slopes are the exact same, right? They're both 2/3, which means that these lines are parallel and they are never going to intersect, which means that this is another one of those special types. There is no solution. And that's it. So today we wanted to take a look at systems by graphing, and by now you should be able to say that you can solve solutions of systems of linear equations in two variables by graphing.